So I'm Cami Sawyer, as Jim said, and I'm not talking about the curriculum, but I'm talking about stuff related to the curriculum. The stuff that may seem to have gone away with this new iteration of the curriculum, but it's still part of how we think mathematics should be taught. It's just the curriculum doesn't cover that so much anymore. So we'll be sharing those links with you so you know where to go on the ministry website to get that information. So today, what I want to talk to you about is it's problem solving. And I'll tell you why I call it investigations instead of problem solving. So thank you so much for being here today. Lisa talked a lot about the professionalism and how amazing it is that you guys are giving that part of, I don't know about you, I'm in Palmerston North. Today is a stunningly beautiful day, and I hope it is in the rest of the Motu. See if I can get that to click. Okay, so I have gone and read a lot of research, so you don't have to, or you might want to too, and so you might question how I've summarized the research. I've took some time and went and read up on, what would the best problem solving tips be? What should we be doing in our classrooms? And, is it different if you're with lower years, upper years? And I decided, no, it's not really. And that I can come up with 6 tips that I think everybody should be using in their classroom. And that's basically what we're going to talk about today. So we have the math processes that are still, part of the curriculum, included as part of the curriculum. And one of those is investigating situations. We have the comprehensive teaching and learning program for how is it best to teach math. And there we talk about rich tasks. And so I'm going to briefly talk about both of those 2 things. And again, we can share those links to the ministry website on those. And then I'll get into my 6 problem solving tips. So investigating situations is one of the 5 math processes. So investigating, connecting, representing, generalizing, and explaining and justifying. Those are the math processes. Those are still crucial to how people learn mathematics and statistics, and crucial to hopefully how we're teaching it. We called it investigating situations in the curriculum instead of calling it problem solving. Why don't we call it problem solving? Well, look at the look on this girl's face, and you might see, why does math have so many problems? There's lots of jokes about that. And really, it's just wanting to use mathematics and statistics to explore our world. So we decided to call that investigating situations. And you could, use that to try to help change your vocabulary if you wanted to. We can still, I'm sure textbooks and stuff will still call them, here's problems to solve. We'll still probably call them word problems, but you could just call them worded situations, worded questions, and not put this notion of problem as to problem, because it's not a problem. It's something, it could be something fun. It could be something I want to come struggle with. It's something to look at and consider. So when we talk about investigating situations, we mean investigating all sorts of things. So including tasks, activities, problems, investigate what you wonder about, what you notice, different contexts. So investigating situations could be about real world maths or mathematical modeling, but it can also be lots of other things. So take it kind of in its widest kind of view. The other thing that the ministry gives advice on is a comprehensive teaching and learning program. What are our best suggestions on how best to teach mathematics and statistics? And we narrowed it down to these 4 things. And this is still the advice from the ministry, even though it's not specifically in the curriculum now. It still comes alongside. It's a curriculum support. These are still our best suggestions. And so it's using explicit teaching, making sure there's lots of communication going on in the classroom between the students, between the teacher and students, between, you know, any combination, making sure communication is happening. And Megan, she was talking about using vocabulary, word walls. That's part of building their ability to communicate. You know, Lisa has done some good research on positive relationship with math and the importance of that. And she, in her talk this morning, talked about the need for students to realize it's okay to struggle. I think Megan talked about that a little bit as well. And it's like how some struggle can create engagement and building those positive relationships with math for students. And the fourth one here is rich task. So what do we mean by rich task? If you look, some people have really kind of restrictive views on what a rich task is. But just like we interpreted investigating in its broadest sense, we want to do the same with rich task. So rich task, to me, and from the ministry perspective here, means are meaningful investigation experiences designed to invoke curiosity and engagement. So they help with positive relationship with math and help with the students communicating and can be guided by explicit teaching. So rich task can include problem solving, word problems, or worded questions if you want. They also can be those kind of, I think what people often think of when we say rich task are bigger non-routine problems, tasks that students do not have a ready-made solution to, methods that they know exactly what they're going to do or what they're going to apply, but it still uses knowledge that they already have. It's building up, and you know, maybe more mathematical modeling where they have to interpret the question and think about and decide how they're going to approach it. So that's what I mean by a non-routine problem. So now that we got that out of the way, so this comes from the guidance of investigating rich tasks. Here's my top 6 tips that will count down from 6 down to 1. And these come from research, and I don't think they'll surprise you, but they may not be exactly what you expect. So if we pause for a second and you thought, well, if I was going to talk to a new teacher or somebody and give them 6 tips on how to use mathematical investigation or problem solving in their classroom, you know, what would your top 6 be? And so here's mine that come from research. This is maybe the most surprising and the hardest. And this is the one I'll kind of leave as my challenge for you today. Try to use math investigation, problem solving at least 3 times a week. And now remember, we're taking this in its broadest sense. So we're not saying you're going to do non-routine problems, a big mathematical investigation 3 times a week. That's not very likely. So we mean all the things that could include. So, and we mean that it can happen in all different ways. Like maybe you just start your class and everybody's thinking about the same worded question. Or maybe after you've done a starter and the class is getting going, you then all together are working on worded questions, or, you know, maybe in individual groups, maybe as a whole class, or maybe you're doing it at the end after you've worked on some new skill during class and you want to see, well, how does that go over in when I have to interpret a question and recognize what I need to do there. So 3 times a week, but in all sorts of different ways. You can use your problem solving for different purposes as well. Again, it can be part of your getting started, maybe a motivational hook into the learning that's coming. It can be, you know, introducing new concepts and have kids like bringing what they're thinking to the forefront and how are they going to approach it before going on and doing some explicit teaching. And it might just be to apply what they've been learning. So there's not one way to do this. But again, here's my big challenge: 3 times a week. Do you already do it that often? Do you already have kids solving problems, investigating mathematical situations at least 3 times a week? So if not, that's my challenge. What kind of situations do we use them in? Number 5 tip is relatable situations. You want the kids to have connection to them. And so again, relatable situations, this is why we have those relationships with our students, and it's whatever interests them, right? And so there's all sorts of things that interest our students. And it can be relatable if it's just what they're wondering about their math and statistics learning, right? If they're in that, if you get them thinking about, what do I notice here? What do I wonder about? What am I generalizing? Often you could take a generalizing and turn that into a problem-solving situation. So taking what the students are thinking about or what they're interested in, make the problems relatable. They don't have to solve problems by themselves. Megan was talking about in her session, having the kids work on their game like in groups of 2, so they could talk to each other and, possibly go off on different ways, but then still being able to think about it together. Mixed ability groups, the research around this says that gives the students the broadest view into the different types of solving. They're less likely to see just one way of going forward, and to see that problems have more than one way forward, or there's more than one way to think about it or interpret it. And that's helpful for students to not think, oh, everybody sees things just the way I see them. One important note about using mixed ability groups is that, as a teacher, you need to make sure you're creating an inclusive learning environment for the students. So, maybe that's agreeing with the students on ways that they're going to work together so that everyone's included and all ideas are valued, and, you don't have students putting each other down. A key part of working in groups, and one of the key skills they're learning in that, is their communication, and in particular their mathematical communication. How are they talking with each other? And one of the other things the ministry has is we have a poster, a prompts for math talk, that you can go on the website. Again, we'll have the links to share with you, but a poster where you can go in and you can print that out and put it up on your walls. But it gives some prompts when the students are working with each other. Maybe I disagree with what they're saying, and the prompt says, I disagree with, you said blah 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 because, and a different way to think about it, or to build on what you're saying, and give the students some support in that so they know how to work together. So you're encouraging students to actively listen, check their ideas with their partner, and not just go, this is the way it is. Do you agree with this? Are we headed in the right direction? Share their thinking, use that mathematical vocabulary. It's like, this is what I want to explain to you, but I can't quite think how to explain it, and so building that vocabulary up and add to their learning. Number 3, counting down, accessible and challenging. So you want to plan for investigations that are accessible to all students and offer different levels of challenge. One way to do this is to use rich tasks that have multiple entries and multiple exit points. So more than one solution, more than one way, and that also helps encourage that discussion and keep students from thinking, oh, I know the answer. There's only one way to do this. Mathematical modeling provides really good ways to do that. If they have to work together and think, well, how are we interpreting what the question is in the beginning, right? And deciding what they're going to go and solve. But there's other problems that, you can allow it to open up, and, depending, you can have the students input different information into the question so that there'll be different solutions. So low floor, high ceiling task is a really nice way to make them accessible and challenging. And Tahurangi, if you search in Tahurangi for rich tasks, you'll find examples that do that. And another place to look is in the acceleration and extension supports that the ministry provides. Something that every teacher can do is use enablers and extenders to help students access their learning. So enablers are strategies to reduce barriers, allow students to engage successfully, and extenders are strategies used to deepen understanding. So, I went to a talk by Lisa a few years ago, some of her previous research, where she talked about, a teacher realizing that a student was going to have trouble cutting out whatever they needed to cut out in order to get into the math task. And so she decided to pre-cut up some. And then it was interesting because they were able to see, oh, not only that student was, use those, but other students decided that they didn't want to do the cutting, or that they were going to struggle with it. And so by enablers, you're opening it up, giving new students different opportunities. Also, it's like, what materials do you have out and available? If you have them out and you're thinking about one particular student might be wanting to use those, but then other students might come in and think, oh, that might help me think through this, or give me another approach. So it can be visual aids, scaffolded entry points, or strategic prompts that guide the students. For extenders, help push students onto thinking in new ways, can add complexity to problems, apply learned concepts to new scenarios, and ask students to consider and compare multiple ways of solving the problem. Is that the only way to do it? And again, that's the mixed ability group can help them try to see stuff from another perspective. I'm looking at the time to see, I think I'm going to skip this now. I'll show it to you, give you maybe a chance to sketch it down if you haven't seen it before. I have a feeling many of you guys will probably have seen this problem before, but I don't think we're going to pause and do this problem today. So the question is, you have this square that has been divided in a particular way, and you can shade any two sections in the square. And then what fractions can you make? And maybe the opposite, what fractions can't you make? So if you want to think about this problem, it's a really nice problem to think about. I'll give you just another quick minute to sketch, and you can think about it later or ask me to put it up at the end of the talk. But this is a nice one to think about. How would you use enablers and extenders? So if you had a student, or if you're going to give this to a group of students, would all students approach it in the same way? Would you, like I'm doing right now, have the students draw it from something you put up on the board, or would you hand out pieces of paper? Would you provide scissors so they could cut it up? Would they also need the original square to compare it to, so they can always think about the one whole? So those kind of things are the kind of things you could use for enablers. And then you can also think about, well, what if a kid finishes quickly? What can I help them for extending them? So here's just a few enablers and extenders that the PLD providers have thought about. I really like the extender of using 3 sections instead of 2 sections, or designing their own different square. So that's the idea of any problem solving, low floor, high ceiling. The low floor is you're giving them lots of enablers to get into it. The high ceiling is you're thinking about the extenders. So before you give the students the problem, you want to think about how are you going to enable and extend so all students can participate. And again, the ministry has acceleration and extension supports that you can find on Tahurangi that can help you think about how to make problem solving accessible and challenging for all your students. We were counting down. We're down to 2. What's the number 2 key tip for problem solving? Plan for decoding and comprehension of text. You might think this applies most to little kids, but I think most of us know that this doesn't, that you have older kids, second language learners, students who just struggle to read, who you have to think, this is a lot of reading on that page. You know, maybe the writing is really small, maybe it's crowded. What do I need to do so I can think about how are they going to approach this text, comprehend it, so they can even start working on the problem? So you definitely have to think about that with little kids. Do they have access to being able to read this? Or are we going to read it as a class and decode it together? But I need you to think about that for your kids all the way through. I've had second language learners, you know, in a calculus class where we're doing like a classic fence optimization problem. And the student's like, I don't know what a fence is, you know, and it's like, if they don't know what a fence is, how can they think about optimizing the paddock, or they don't know what a paddock is, you know? So really think about how can we help the students decode and comprehend the text. So when choosing appropriate investigations for your students, consider the math in the question and the text of the question. Before a student understands the math of the question, students need to read the question. Ensure students have the vocabulary and general knowledge required to comprehend what the question is asking. And you may need to provide scaffolds or supports to do that. So it may be that they have a dictionary, but it may be that it's a discussion or building, you know, creating a picture of what's going on to help them decode before they get into the math of what's going on. So plan for that as part of planning to use problem solving. And the number 1 tip. Oh, sorry. I thought I was at number 1. Sorry, I'm still at number 2. A little bit of warning from the research. Don't highlight keywords. Does that surprise you? Surprised a lot of my colleagues, especially my English colleagues, the ones who specialize in the English curriculum. They were like, what do you mean? That would be the first step I tell teachers to use. The problem in math is that it can often lead kids into thinking that they're doing the wrong, lead kids into doing the wrong operation. There was some nice research out of that, of the University of Waikato about 15 years ago around that. So here's just a quick example. And we'll look at this problem a little bit later too. But Sarah has some blocks. Then she got 13 more blocks. Now she has 80 blocks. If you are highlighting keywords, I haven't even read the question part, but just looking at the setup part, you might highlight more. You might have told a kid to highlight more, but that might encourage a kid to go, oh, I'm adding on. And then the other number they see is 80 and go, oh, so my answer is 80 plus 13. Right? So instead, we need to think about decoding the problem and think about what's really to comprehend. So, you know, instead, I want to picture Sarah having a group of blocks, getting 13 more, and then the total she has is 80. And so I don't want to just highlight that keyword maybe of more, because that would send me down the wrong track. And again, lots of good research and good examples how highlight, if you kind of teach kids to think every time you see less than or more, that can really get kids into problems with their problem solving. Okay, so the number one key key advice for how to solve problems, how to use problem solving in your classroom is to explicitly teach a structured approach. And I know not everybody thinks this is the best thing to do because this can lead people to think there's only one way to do it. Again, you might want to talk to Lisa Dara about this. But we think having an approach so kids know how to get into solving the problem. So being explicitly taught a way to do it and then solving lots of problems so they can see, oh, sometimes I have to go through all the steps, sometimes I don't, sometimes I switch around. But having a structured approach at the beginning helps to set kids up. And the ministry has provided some of those for you. So one, we have our Maths Investigator poster, which you may or may not have seen. That's newish. So I'm a maths investigator, and we're going to go through that as part of this number one here. And then hopefully everybody has seen the PPDAC cycle, the problem plan, data analysis, conclusion, that can be used with both statistics and probability to think about how to explore data. And the Census at School New Zealand has really, really great resources for using that one. So I'm not going to talk about the statistics right now. I'm going to talk about the Maths Investigator. So here's that poster. Again, you can go onto Tahurangi and download and print it for your classroom. So if we think about that problem I gave you earlier and think about using this Maths Investigation cycle, we could think about, how would teaching that investigation cycle help a student approach this problem? So the very first step, make sense of the problem. So this is part of that decoding. This is really kind of our previous step. We've made sure the students have access to the problem, and now they need to make sense of the situation. So connect to what they already know, think about what can change and what stays fixed, or maybe pose their own question if it's a mathematical modeling situation. We've already planned for decoding and comprehension, but now we're going a step further. We might provide materials, pictures, have the students discuss it, maybe act it out. Like I was saying with our problem with, we have some blocks and then we get 13 more and we have 80 altogether, drawing a picture, thinking about how it fits together. Maybe restating the problem in their own words. That's a really classic one that works very well. Simplifying the problem down, only looking at part of it, not thinking about the whole thing. Notice I still haven't been thinking about the last part of the question yet. And so start with just one part of it. So those are all part of making sense of the question. So if we think again about Sarah had some blocks, then she got 13 more blocks. Now she has 80 blocks. If you pause for a second, if you haven't already thought about the solution here, would you draw a picture? Would you act it out? Would you restate the problem in your own words? Would you simplify? Again, I've been simplifying that because I keep not even reading that last part. By what fraction did her original amount increase? So I'm still just thinking about the original setup. Step 2, plan your approach. We haven't started solving the problem yet. We're just making sense of the problem. And now we're going to express the situation using math, consider and choose a way to investigate the question. What am I going to do next? What's my approach going to be? Some things, again, that can help me when planning my approach: draw, list, discuss, estimate. We probably don't emphasize estimate enough. Estimate. Have the students think, well, what answer even makes sense before they get into the point of actually solving the problem. So again, for Sarah and her blocks, maybe before solving it first, you're going to estimate how many, Sarah had some blocks, estimate how many blocks that was before even thinking about the increase, the fractional increase. So breaking it down, estimating, drawing, discussing. So plan the approach. Still, we haven't even started solving it yet. Then we're going to take action. Investigate the question using the way you choose. Look for patterns and relationships and answer the question. Some things that can help with taking action: solve, answer, record, explain. Doing the work. The taking action is your solving step. Using correct notation. That's another thing. So again, if you haven't done it already, you might go back to the Sarah problem and try that again. And now we see that we had to do 80 minus 13. So that's why if we highlighted more, it would have caused us a problem. We estimated that, I'm not taking away a whole 20, I'm taking away more than 10, so it's somewhere between 60 and 70, closer to 70, and then go, oh, it's 67. So writing that out using correct mathematical notation, teaching kids how to write that down. And then by what fraction did her original increase? So her original was she had 67 original blocks and she got 13 more. So we're looking at 13 out of 67. And we might estimate that. It's not, the numbers aren't really nice there. But if we wanted to reduce the fraction, see if it reduced, estimate it first before putting it in a calculator or breaking it down using factorizations. 13 is nice since it's prime and it doesn't factorize. You should check to see if it divides into 67. Convince yourself and others is the fourth step. So we make sense of the problem, we plan our approach, we take action, and then we convince ourselves and others. That's when it helps to be working with a partner or a couple partners. We explain and justify the solution. We reflect on our own and others' investigations. If somebody says, but I did it differently, talking about that, explaining and justifying, generalize the findings. Well, what else do I notice and wonder? What did I think I could do this in general? What if I wanted something that turned up with nicer numbers? Could I have thought of a way to do that? And communicate my findings. Maybe I want to think about what my answer is in percents or something. So check answers at this point and compare with those estimates. So that's why it's so important to make an estimate. So I can say, was I in the right ballpark? And if not, maybe I need to go back. So this is a structured approach to problem solving. If those steps seem familiar to you, might go back up to the poster here. Sorry, it's going to take me a second to get back there. This is based off of Polya, but some great mathematical and statistical minds in New Zealand came together to help us come up with this poster to think, what approach can we encourage every teacher in New Zealand to be using with their students so they have a way to approach problem solving or mathematical investigation. Back to the end. So here's my 6 top math investigation tips. They're not just mine. Again, I read a whole bunch of research so that you didn't have to. So at least 3 times a week, that's my challenge to you. Relatable situations. If you live in Palmerston North, maybe you're not choosing to do problems about, highway entrance ramps, or, if you live someplace a lot smaller, maybe you're not doing things about stoplights. So, or if you live in a big city, maybe you're not doing stuff about sheep. So thinking about your students and what makes sense. Having students work mixed ability, but with guidance, giving them a poster or information, ways to talk to each other so they can help each other and it can be a positive experience. Make the problems accessible and challenging, that low floor, high ceiling, enablers and extenders. Plan for decoding and comprehension of the text, and explicitly teach a structured approach. Those are my key tips. And yeah, trying to make sure I end with a little bit of time if you wanted to ask me questions about math investigations or rich tasks or problem solving tips. Or if you want to put in the chat, what are your favorite tips that I haven't included here? Because of course people have other tips. Or do you do it 3 times a week already? Do you have a way to do it 3 times a week? How are you encouraging students to do that? And yeah, what was the thing I said I could put back up at the end? Oh, I could put that back up if you wanted it, or I can just stop sharing and I can put into the chat those links so you can access the stuff on Tahurangi. So the math processes, there's 5 of them that we talked about at the beginning, investigating situations being the first one. And you'll see how ugly the website domains are from the ministry. Sorry about that. And the flower picture that I showed with the comprehensive teaching and learning model, with the rich task, positive relationship with math, explicit teaching, and communication, making sure those are all part of your learning. The guidance on that is there. And if you just want general guidance on teaching mathematics in New Zealand and the guidance from the ministry there, this last page leads you to the whole page, and there's all the different resources, and you have to go to the bottom and click more because they're done in the little tiles and you don't see them all.
Okay, Cami, there's a question in the chat here. It says, mixed ability, is there a range of curriculum levels, sub-levels that optimize this?
No, I think then that's thinking about, what's your goal of your teaching that day, or why are you including this investigation? What's the goal of doing it? We talked about there being different reasons why you would do the investigation. And so is it your motivational hook? Are you introducing a new concept, or are they applying what they already know? So thinking about what the purpose is, and then thinking about, which kids work well together in order to do that. So I think it has to come with the purpose.
Okay. All right. Are there any other questions that there we go. Is there any other questions that anybody has? If you could put your hand up, please. Oh, there you go, Cami. You've answered all the questions in your presentation.
Here's one from Simone. Can I comment on initiatives to build those positive relationships? Building relationships with your students and then building positive relationships with math. And it is hard the longer they've been in the system and had more chances possibly to be traumatized by it. Again, back to Lisa's talk earlier today, and if they've learned that that they're only motivated to do math because they've gamified systems rather than intrinsically finding it interesting to be challenged. It is hard, but the ministry is working on providing more information on positive relationship with math. I would encourage you to look up Naomi Ingram's research. She worked with high school students and has really insightful research. She was the keynote at NZANT in Dunedin this year. And I think if you looked at her resources from there, you might find some really useful input.
Okay, anybody else?
Again, thank you all for giving up some of your beautiful Saturday to do this. And if you're watching the video later, whatever time, you're giving up your time to be here. And I appreciate you letting me share this with you.
All right. On behalf of the AMA, Cami, we'd like to thank you very much for your time. We've gathered a lot of information about how to present a task to a student from the floor and working it all the way to the ceiling that has multiple solutions along the way, and multiple ways of solving problems. So, as I said, on behalf of the AMA and myself, thank you very much for your time this morning, and we look forward to having you back in the near future. So, thank you.
Thank you. Have a great day, everyone.